Welcome to The Explainer. Today, we're talking about a technology that's literally teaching machines to see. And in the process, it's changing, well, pretty much everything, from how we diagnose diseases to how we get from A to B. We're going to dive deep into computer vision. So let's just start with a really simple question. How does a self-driving car actually see a stop sign? How does it look at that red octagon and know, with certainty, that it means stop? It's not magic, not at all. It's a super powerful branch of AI, and it's completely reshaping how machines perceive the world around us.
All right, so our journey's got to start with the absolute fundamentals. How in the world do you teach a machine, a piece of code, the sense of sight?
At its heart, computer vision is exactly what it sounds like. It's this entire field of AI focused on one thing, training computers to process and make sense of visual data. You know, what's totally intuitive for us, like recognizing a friend's face, or a tree, or a car, that's an incredibly complex puzzle for a machine to solve.
So, how does a computer actually see? Well, it's basically a five-step process. First, it's got to acquire an image, right? Then it preprocesses it. You can think of this like cleaning a dirty camera lens to get a clear picture. Now, step 3 is where the real magic happens, feature extraction. This is where it identifies the building blocks of the image, all the edges, the corners, the colors. From there, it moves on to recognizing patterns, and then finally, it makes an interpretation. It puts it all together and says, aha, that's a stop sign.
Now, for decades, this whole process was honestly pretty slow and clumsy. But then a massive breakthrough happened that didn't just speed things up, it completely changed the game. And that was the deep learning revolution.
And this slide just illustrates the shift perfectly. See, in the old days, engineers had to sit there and manually code rules for every single feature they wanted the computer to see. Look for a straight line here, a curve there. It was so laborious. But with deep learning, which is powered by these amazing models called convolutional neural networks, or CNNs, the machine learns all the important features on its own. It's kind of like a baby learning to recognize a face. You don't tell the baby, look for a nose and 2 eyes. It just learns the pattern by seeing lots and lots of faces. It went from being told what to see to actually learning how to see. A total game changer.
Okay, so this isn't just some theory stuck in a research lab. This technology is already out there in the real world, integrated into our lives in ways that are both seriously profound and super practical. Take healthcare. In hospitals, this technology is basically becoming a second set of eyes for doctors. AI systems are now being trained to analyze medical scans, x-rays, MRIs, you name it. And they're spotting tiny little anomalies like early-stage tumors or hairline fractures that even a highly trained specialist might overlook. It's all about finding problems earlier and with way more accuracy.
And this brings us right back to our self-driving car. Its ability to navigate a chaotic city street, that's pure computer vision. It is constantly identifying road signs, tracking pedestrians, predicting what other cars are going to do, and it's doing it all in real time. This exact same core technology is what guides everything from delivery drones to the robots that build things in our factories.
Speaking of factories, manufacturing is all about precision, and that's where computer vision really shines. Just imagine an inspector on an assembly line that never blinks, never gets tired, and can spot a microscopic flaw on a part that's zipping by at high speed. Well, that's exactly what these automated systems do. They ensure perfect quality control 24/7.
But, and this is a big but, as powerful as this all sounds, the technology is not perfect. Not by a long shot. So it's really important that we understand its current limitations and also take a peek at where it's all headed next.
So here's the deal. Computer vision can be superhuman at very specific, very narrow tasks. But it can really struggle with real-world messiness, things like poor lighting, weird angles, or situations it just wasn't trained on. And one of the biggest challenges is its black box nature. A lot of the time, even the engineers who built the AI don't know exactly why it made a certain decision. And that's a huge problem, especially in high-stakes fields like medicine or self-driving cars. The good news is the future is all about solving these problems. We're seeing a big shift toward processing data right on our devices. That's edge computing, which is faster and better for privacy. Researchers are also combining vision with language and sound to build a much richer understanding of the world. And there is a massive push for something called explainable AI, or XAI, which is all about prying open that black box to make these systems transparent and trustworthy.
And that brings us to what might be the most critical part of this whole conversation.
Because with any technology this powerful, we have to confront the huge ethical questions that it brings up. This quote just nails the heart of the problem. If an AI is trained on data that reflects our own historical biases, guess what? The system will learn those biases, and in many cases, it will actually amplify them. A classic example, if a facial recognition system is trained mostly on images of one demographic, it's going to be way less accurate for everyone else. And that can lead to some seriously unfair outcomes. And the questions just get bigger from there. How do we balance the need for security with our right to privacy in an age of mass surveillance? What does widespread facial recognition mean for our civil liberties? And maybe most importantly, how do we stop this incredibly powerful tool from being misused? Look, these aren't just technical problems anymore. They're societal problems, and we all have to figure them out together.
So we'll end with this thought. We are actively teaching machines the incredible, powerful ability of sight. But the ultimate challenge, it might not be about making them see more clearly. It might be about deciding what things, for the sake of our own privacy, our fairness, and our humanity, we should program them to completely ignore.